This conference will now be recorded.
Okay, very good morning to all the participants of second year A section and B section. I welcome all of you to the next important and crucial session in electromagnetic fields, as we are planning to cover one important topic and the last topic in your second module, which I already said. The boundary conditions is the actual title. Very important question. Definitely, as I said previously, either in any one unit, definitely you will get this particular question. Like it can be from second module, or it can be from third module, or it will be from fourth module. So in any one of the modules, definitely this particular question will be there. For one particular batch, Anna University question paper, it was like 2 boundary conditions questions has been asked. Okay, from 2 units. Okay, so that is also a possibility available, but nowadays it will not happen. We should not aim for its lowest possibility, lowest priority. Okay, so definitely one question will definitely come from this particular module, from this particular topic, I can say. Okay, so what we are going to see is actually what is meant by boundary condition. That is our starting point. Definition. It is also important for 2 marks. They may state or ask like what is meant by boundary conditions sometimes. Important thing what we will be seeing after what is meant by boundary condition is the statements. What are the statements of boundary conditions of electrostatic fields? That is our next important division. After seeing the statements and definition, we will be entering into the proofs, because we are having actually 2 statements. So first statement will be there. In second statement, 2 subdivisions are there. So for all these things, we have to see the corresponding proofs also. So statement and proof, it is important. Along with that, refraction lines of forces also we have to derive. Okay, refraction lines of forces also we have to derive here. So that is what we are going to cover today. And according to the time limit which is available after completing boundary conditions, if time is there, we will work out some problems. Otherwise, with this boundary conditions, we will close our second module, and from our next class onwards, we will start our third module. Problems we will do it combinedly for second and third modules, because they will look alike actually. Okay, so my plan is that to combine the problem session to 2 particular hours. Okay, that is our plan actually. With this, I'll share now the PPT for today's class. 1 minute, I'll share the screen. Yeah, guys, is the screen visible?
Yes, sir, visible, sir.
Okay, thank you. So as I said, today's title is boundary conditions and problems. Agenda for today, it goes like this: revision of the previous class, boundary conditions for electrostatic field, problems summarization, and finally attendance. So as far as revision of the previous class is concerned, in the last class, I request any volunteer to tell what we have seen in the last class. Can anyone? Can anyone tell or revise what we have seen in the last class? Our last class was on Wednesday, 8th of September. Today is 11. Yes, ma'am. Okay. Aishwarya from A section, are you there in the link?
Yes, sir.
Okay. Good morning, Aishwarya. Can you revise what we have seen? Can you summarize?
Sir, we have seen about capacitance of two electric media, sir.
Okay.
Derivation part, sir.
Hmm. Okay. What else?
That's all, sir. Then three dielectric media we have seen, sir. We have seen,
Okay.
sir.
Okay.
Electrostatic energy and energy density, sir.
Okay. That's it,
Then one
right?
problem we have saw, sir.
One problem.
Yes, sir.
Which problem we have seen?
Sir, potential at a point, sir.
Okay.
Isolated
Okay.
sphere, sir.
Yeah. Okay. Okay, Aishwarya. Thank you so much. Thank you for nice summarization.
Thank you, sir.
Yeah. So what we have seen in the last classes, as Aishwarya shared, capacitance, the concept of capacitance we have covered on Tuesday, and its extension. Like if I am having two dielectric media, what will be the expression of capacitance? If I am having three dielectric media, what will be the expression of capacitance? That's what we have derived actually, and for that we have assumed D is equal to Q by A as a constant. Okay, for the entire media, for the entire arrangement, I have assumed D as a constant. And we know some basic relationships. D is equal to epsilon into E is one such relationship. D is equal to psi by A, because electric flux per area is electric flux density. So obviously we have got psi by A, and from Gauss law, psi is equal to Q, we know. So it becomes Q by A. Q by A. Okay. So with that, with those basics, with those concepts, basic concepts of formulae which you know already, we have derived the final expression for capacitance. Capacitance is nothing but Q by V. So for any medium, if we are in a position to derive the potential expression, the expression of potential from electric field intensity, we can easily derive the capacitance value, because V is equal to Q by something we will derive normally. Okay, so once V and Q are known, we can find easily what is Q by V. Q by V is nothing but my capacitance. So if you found Q by V, we can easily write the same expression of Q by V as the expression of capacitance. Okay, so in that way we have taken one such example of isolated sphere. In the same way, we have got coaxial cable, concentric spheres. Concentric sphere means there will be two spheres. It is like a hollow structure. Okay, then coaxial cable or cylinders I can have, then transmission lines, everything. Then we have also covered if two capacitors are in series connection, what will be its equivalent capacitance, and two capacitors are in shunt or parallel connection, what will be its equivalent value. Those things also we have seen in the last class. Along with that, we have seen what is the expression of electrostatic energy stored in a capacitor. We know already that the energy stored in a capacitor expression is half CV square. how we are going to derive it, actually that actually matters. So we have derived that also from the expression of work done. We have potential is nothing but work done per charge. So del W by del V is the actual expression or definition for potential. From that, if I find del W, it become potential into del Q. So what is potential? We know, and what is del Q? That also we know from the basic expressions of capacitance, basic concepts of capacitance, because we have already derived capacitance value from the basics, that it is equal to epsilon AV or A into epsilon T. Okay, with that I can find it actually. Then we have derived that the electrostatic energy stored in a capacitor value is half CV square. With the basics that C is equal to Q by V, we can derive the alternate expressions of energy stored in a capacitor. That's also we have seen. Along with that, finally, we have covered what is the energy density in a capacitor or of an electrostatic field or of electric field, whatever it is. So its value is half dE, where E is the electric field intensity, D is the electric flux density or displacement density, and half dE, or if you want in terms of just E, not D, means we can write it as epsilon E square. Half epsilon E square we can write, or if you want to write in terms of D alone, not in terms of E, that also we can derive, because we know the basic expression or basic relationship between D and E. It is nothing but D is equal to epsilon into E. So using that, we have derived the energy density. Energy density is nothing but del W by del V. That is amount of work done per unit volume. That I am going to call it as the energy density. Density means always it deals with volume parameter. Okay, we know that already, basic. Okay. As far as the course outcomes are concerned, we are in second module, last class. So today is the last day in which we are going to define what is the course outcome for the second module, CO2. It is actually analyze field potentials due to static charges and static electric fields. So it is coming under K4 level, analyze level of revised Bloom's taxonomy. So it is analyze field potentials due to static charges and static electric fields. That is what is the CO for today. Okay. Now we will go into the session of today, boundary conditions. Okay. First, this particular answer is the answer for the first question, that is what is meant by boundary conditions generally. As far as electric field is concerned, how to define boundary conditions. That is what is the answer. Now the answer is, what is meant by boundary conditions means it is the conditions pertaining to normal component of the displacement, comma, tangential component of the electric field intensity and refraction lines of forces are called boundary conditions. Very simple. Okay, the conditions pertaining to the normal component of electric flux density, or I can say displacement density, comma, tangential component of the electric field intensity and refraction lines of forces are called boundary conditions. This is the answer. That is for all the 3 units, second, third and fourth units, you can have this particular definition, but you have to change the terms actually. If I am seeing it for magnetostatic field or magnetic field, means in the place of electric field intensity, you have to write it as magnetic field intensity. In the place of electric flux density, you have to write it as magnetic flux density. That only will change, but the definition will be the same. Now I will come to the statements of boundary conditions. Statement 1, the tangential component of, see, this particular derivation is very easy and interesting also. It is coming from the PR max trigonometry. Trigonometry is the base for deriving this boundary condition. Very interesting derivation, right? Statement 1 is the tangential component of electric field intensity E is continuous at the surface. I'll tell you while doing the derivation, I'll tell you what is the meaning of the word continuous and what is the meaning of the word discontinuous. Okay, the tangential component of electric field E is continuous at the surface. That is the first statement. Statement 2, the normal component of electric flux density, or I can say displacement density, capital D, is continuous when if there is no surface charge density. So if I assume that if there is no surface charge density in the assumed geometry, I can say the normal component of electric flux density will become continuous. But if I assume there is some surface charge density, then I can say D is not continuous, or I can say D is discontinuous. So that is what is the second part of the second statement. Otherwise, D is discontinuous by an amount equal to the surface charge density itself. So these are the two statements which are very, very important. The tangential component of electric field E is continuous at the surface. This is the statement of number 1. Statement number 2 was the normal component of electric flux density or displacement density D is continuous if there is no surface charge density. Otherwise, D is discontinuous by an amount equal to the surface charge density itself. Is it okay? Now, we are going to prove these two statements. That is our task. The question is like obtain the boundary conditions. Obtain the boundary conditions of electrostatic field. Like that they will ask, or they will ask derive the boundary conditions of electrostatic field. In some way they will ask it. Okay. See, for my case, I am assuming such I mean an arrangement of rectangular box. I'm actually assuming. Okay, so it is purely a derivation. So I'll come to the board now so that it will be convenient to explain. Okay, that also you can easily understand if I do it on the board rather than with the PPT. So after finishing the board work, I will come back to the PPT. Okay, now I will stop sharing the screen. I will switch on my camera. 1 minute. Yeah, is the board visible?
Yes, sir. Visible, sir.
Okay, good. Thank you. Good. Right. So the point is, see, if anything is not visible, you please intimate me, like, sir, change the board. Change the board in the sense, if I want to move the board towards left or right, I can do that. Okay. Right. Now, I'll come to an arrangement for proving the. So this is boundary conditions is the actual title. Boundary conditions. Proof we will come for. Proof for first statement. That is what we are going to do. Okay. See, for proving the first statement, what we are going to do is, I am going to assume a rectangular box like this. I am assuming a rectangular box, okay, which is having two parts like this. Okay, and here it is hinged joint. This is actually not that much important, but this is a rigid joint. That is what I want to convey. And I am going to take now the terminals of the rectangle as ABCD. Okay, and I am going to assume the length of the rectangle as del y. So this is del y, and I am going to assume this particular width as del x. I'm going to assume these parameters, and here from starting from A, what I'm going to do is I am going to assume here that is the left hand side portion. I am going to take it as medium 1. This is medium 1, wherein my permittivity is epsilon 1. Permittivity is epsilon 1. This is said to be the dielectric medium. In the same way, right side is dielectric medium 2, where the permittivity is epsilon 2. Okay, and here I am going to assume, okay, the tangential component. I am going to assume here ET1 to be the tangential component, and here ET2 to be the tangential component. And here I am going to assume EN1, the normal component, here EN2. So I will be assuming this particular rectangular box for my proof. You understood, no, what I said? So ABCD is the rectangle. The dimensions of the rectangle is del x by del y. Then I am having ET1, EN1, ET2, EN2, like this. This is my dielectric medium 1, where the permittivity is epsilon 1. This is my dielectric medium 2, where the permittivity is epsilon 2. This is what is my assumption. Okay. Here we know already that if this is the arrangement, okay, the absolute potential or the total potential here will be equal to 0. Okay, will be equal to 0, because I am having two tangential components, both of equal polarity, equal what I can say, equal values. In the same way, En1, En2, these two things will be of equal value, means normally normal components will get cancelled, tangential components will also get cancelled. Okay, what is remaining is my absolute potential will be equal to 0. Okay, so Anas, somebody's mic is turned on. Can you turn off? Yeah, somebody's mic is in unmute condition. Can you mute? Yeah, thank you. So the relation between V and E, we know V can be written as integration E dl. So that will be equal to 0. This is the expression we will be getting it. Is it okay? So this particular point, we are going to use it for our derivation. Is it okay? So we will see now how this can be done. What I am doing here is I am going to apply this particular condition to this rectangle, Now I will make a move to the other side of the board. Is the other side visible?
Yes, sir. Visible, sir.
Right. Okay. Okay. Good. Yeah. So here, what we are going to do is, or otherwise I'll come to the bottom also, so that we can. Okay. 1 minute. Write it at the bottom. It will be right. Okay. Fine. So if I apply this particular condition to this rectangle ABCD, what will happen? It is nothing but I am going to write the expression of integration EDF. Okay. In the side AB, what is going to come is nothing but this can be written as ET1. ET1 is the actual E value. DL here is the length, that is del y. Is it okay? In the same way, if I do it here, what will happen at the top? If I do it for BC side, you might have written the, you might have drawn the diagram. Okay, you can refer to the diagram. Okay, instead of changing the board position, you please look at the diagram. So I will tell the terminals. So for AB, this is the value. For BC, what will happen is it will become plus, because if you take the assumption that a charge is going to flow, it starts its flow from point A. In a rectangle, how it flows? A to B it will go, B to C it will go, C to D it will come, then D to A it will come. Okay, right? Then only it completes the path. Is it okay? So if it is starting from A, et1 del y will come. If I come to the terminal BC, it will become en1. Its length is del x. Do you agree? Okay. After completing it, you look at this particular side. If I come to CD, what will happen? See, it actually has to travel from C to D, but the arrowhead is pointing in the upward direction. That is in the opposite direction of our assumption. So what we have to do normally? We have to change the polarity. So it will become et2 del y. Okay. புரியுதா கண்ணா? நம்ம ஆக்சுவலா எடுத்துக்கிற டைரக்ஷன் ஏபி பிசி சிடி டிஏ. ஆனா இங்க நம்ம அசியூம் பண்ண டைரக்ஷன் எப்படி இருக்கு? அப்வர்டா, which will oppose our பாயிண்ட் இல்லையா? அப்ப வந்து மைனஸ் எடுத்துக்கிறேன். அதே மாதிரி லாஸ்ட் டைரக்ஷன் டிஏ எடுத்துக்கும் போது எப்படி எனக்கு இருக்கணும்? ஃப்ரம் டி டு ஏ இட் ஹேஸ் டு ஃப்ளோ. பட் என்னுடைய en1 அசம்ஷன் எப்படி இருக்கு? en2 அசம்ஷன் அதுக்கு ஆப்போசிட்டா இருக்கு. அப்போ what we have to do is we have to change the polarity. So it will become en2 del x. And according to this particular statement, this will be equal to 0. I can. Is it okay? இந்த ஸ்டேட்மெண்ட் யாருக்கு புரியல? இந்த ஸ்டெப் அதாவது absolute potential, here I am assuming it as 0. If that is the case, V and E relationship we know, so V can be written as integration EdL, which is equal to 0. Now for this rectangle, I am going to find the left hand side. If I do that, I will get this one. See, et1 del y en1 del x minus et2 del y minus en2 del x. That will be the expansion for this particular integration. That will be equal to 0 here. Okay. Now what I am doing on assumption. What assumption I am going to do here is, for example, I am having two sides here, the vertical sides AB and CD. Okay. What I am doing is I am bringing AB and CD close together. Okay. If AB and CD are brought closer together, what will happen? If I do that, what will happen is del x will be equal to 0. Correct? நான் இந்த ரெண்டு சைடு கம்ப்ரஸ் பண்றேன். ஓகே, அப்ப என்ன ஆகும்? இந்த லென்த் வந்து காணாம போயிடுமா? அப்ப del x will be equal to 0. இப்போ இந்த del x equal to 0 அப்படிங்கிற வேல்யூ I am going to put it here in the expression. What will happen? et1 del y will be there. This term will become 0. Do you agree? கரெக்டா ஃபாலோ பண்ணுங்க, உங்களுக்கு ஐடியா கிடைக்கும். இந்த term 0 ஆயிடும், ஏன்னா del x 0. Similarly, this term will be 0. Why? Because del x is 0. Okay. So what is remaining? et1 del y minus et2 del y equal to 0 ன்னு கிடைக்கும். So இப்போ et2 del y அந்த பக்கம் எடுத்து போயிட்டா என்ன ஆகும்? et1 del y will be equal to et2 del y. Del y cancel ஆச்சு அப்படின்னா the answer is et1 equal to et2, which is our required expression. நம்மளுடைய ஸ்டேட்மெண்ட் என்ன சொல்லுது? What is the statement number 1? The tangential component, அதாவது இங்க et1 ன்னு போட்டிருக்கேன் இல்லையா, இது எப்படி எழுதலாம் அப்படின்னா tangential component of electric field intensity in medium 1. That is the expansion for et1. In the same way, et2 னா என்ன? Tangential component of electric field intensity in medium 2. What is en2? en2 is nothing but normal component of electric field intensity in medium 2. In the same way, en1 means normal component of electric field intensity in medium 1. சரியா? So what I can write now is et1 equal to et2 na enna aidum? Tangential component of electric field intensity in medium 1 is equal to the tangential component of electric field intensity in medium 2. So these two are equal அப்படின்னா what does it mean is it is said to be continuous. நான் வந்து மீனிங் சொல்றேன்னு சொல்லியிருந்தேன் இல்லையா? continuous அப்படின்னா எப்படி வரணும், என்ன அர்த்தம் அப்படின்னா this is the meaning. Continuous means the two values will be equal. So இதை எழுதிட்டு கீழே என்ன எழுதிக்கலாம்? Hence the tangential component of electric field intensity is continuous at the surface. So that has been proved here. In that way we can stop. இதுல யாருக்காவது டவுட் இருக்காப்பா இந்த டெரிவேஷன்ல? By taking a rectangular box, how we have done it? Any doubt in this? If you have any doubt, you can ask me.
No, sir.
No doubts. Okay. Any doubts to anybody? Okay, this is the statement number 1 actually, right? Shall I erase now? Have you all taken?
Yes, sir. Yes, sir.
Okay, thank you. Next, we will be entering into the second statement proof. So as we all know, second statement has got two halves, okay, two subdivisions for its proof. Okay, first part separately we will do it actually, but by taking the same geometry, same arrangement, okay, we will be deriving both. So for that, what I am doing is, for the second statement, I am actually proving now. Okay. So what I am going to do is, I am going to take an arrangement named a pill box. We call it as pill box. P-I-L-L box. Pill box. Pill box arrangement. So pill box means how it looks like. It looks like this. Okay. And here I can have two mediums. So let us take the top portion is medium 1, whose permittivity is this. So I'm writing here. Left hand side is it visible? Board. This is dn1. This is dn2. And this particular height of the pill box is del x, right? And here the area can be taken as ds. Is it okay? Is it okay? This is the pill box arrangement which I am going to consider for the proof of second statement. Is it okay?
Yes, sir.
Height of the pill box is del x dn1 dn2, I have assumed, right? Okay. Now what I am going to do for proof is, I am going to apply Gauss law to this particular pill box. So what is Gauss law? Gauss law என்ன சொல்லுதுங்க? Gauss law is nothing but is d is equal to psi by a, or I can say q by a. இல்லையா? So நம்ம எப்படி q எழுதலாம் அப்படின்னா dA ன்னு எழுதலாம் if it is mathematics, but in our subject we will be writing it as integration d ds. கரெக்ட்டுங்களா? இப்படிதான் நம்ம q எழுதணும். நான் இங்க என்ன அஸ்யூம் பண்றேன் அப்படின்னா, எனக்கு வந்து சார்ஜே கிடையாது, இந்த pill boxல வந்து சார்ஜ் கிடையாது, because there is no charges enclosed by the pill box. Okay, what will happen here is q will become 0, so I can write integration d ds equal to 0 அப்படின்னு எழுதிக்கலாம். ரைட்டுங்களா? அப்ப எனக்கு ரெண்டு மீடியம் வருதா இங்க, so I have to divide this medium. So என்ன பண்றேன், integration dn1 ds minus integration dn2 ds will be equal to 0. ஏன் இங்க மைனஸ் வருது, யாராவது சொல்ல முடியுமா? Why here a minus is going to come? இது போன டிஸ்கஷன் மாதிரியே தான். என்னன்னா, எந்த டைரக்ஷன்ல ஃப்ளோ ஆகுது, நாம என்ன டைரக்ஷன் அஸ்யூம் பண்றோம். இப்ப நான் வந்து பாத்தீங்கன்னா ஒரு இதுல ஒரு சென்டர்ல இருந்து ஒரு சர்க்கிள்ல இருந்து, if it is going out, if I take that as positive, this is going out, so this is taken as positive. But here what happens, it is actually entering, so this is leaving out, this is entering. So dn1, if I take it as positive, automatically dn2 will have negative value. Is it okay? So this particular q, why it is coming here is, I am assuming there is no charge here. No charge is enclosed by the surface. But surface of the pill box means q will become 0. So right hand side will become 0. So this one I can write it as dn1 ds is equal to dn2 ds. So என்ன எழுதலாம் கடைசில, dn1 equal to dn2 ன்னு எழுதிக்கலாங்களா? Because ds with integrations gets cancelled. அவ்வளவுதாங்க. சோ இங்கேயும் பாத்தீங்கன்னா அதேதான். dn1 எப்படி சொல்லலாம் அப்படின்னு கேட்டீங்கன்னா நார்மல் காம்பனன்ட் ஆஃப் எலக்ட்ரிக் ஃப்ளக்ஸ் டென்சிட்டி ஆர் டிஸ்பிளேஸ்மென்ட் டென்சிட்டி இன் மீடியம் 1. Similarly, dn2 is nothing but the normal component of electric flux density or displacement density in medium 2. இந்த ரெண்டுமே ஈக்குவலா இருந்துச்சுன்னா என்ன அர்த்தம்? They are continuous. இதுதான் ஸ்டேட்மெண்ட். சோ இங்க என்ன கீழ எழுதணும், இது கீழன்னு கேட்டீங்கன்னா hence the normal component of electric flux density or displacement density is continuous if there is no surface charge density. If there is no surface charge density அப்படின்னா q value is 0 because rho s equal to 0 அப்படின்னா நான் அஷ்யூம் பண்ணிருக்கேன் இல்லைங்களா. rho s அப்படிங்கிறது என்னங்க, சார்ஜ் தான். if I take a surface charge density, how q can be written rho s ds. so rho s 0 அப்படின்னா q 0 தான் இருக்கும். அத தான் நாம அஷ்யூம் பண்ணிருக்கோம். சரிங்களா. so this is what is the proof for the first half of the second statement. Any doubt in this? இந்த ப்ரூஃப்ல ஏதாவது டவுட் இருக்கா?
No doubt sir.
No doubts. Okay, very good. இப்போ second half of second statement என்ன சொல்லுங்க? What is the second statement? I mean second half of the second statement. அங்க நம்ம என்ன சொல்றோம் அப்படின்னா surface charge density இல்ல அப்படின்னா என்ன ஆகும்ங்கிறது தான் first statement. second statement என்ன சொல்றாங்கன்னா if there is a surface charge density, okay, there is a charge, அப்ப என்ன ஆகும் அப்படின்னு கேட்டீங்கன்னா q cannot be taken as 0. இந்த ரிலேஷன்ஷிப்ல அதே தாங்க. q cannot be taken as 0 now. Am I right? so q வந்து 0 ன்னு எடுக்க முடியாது. என்னன்னு எடுக்கணுங்க, there is some volume because we cannot deal with area now because the pill box has got a particular height also. ஒரு ஏரியா இருக்கு, அது கூட ஒரு ஹைட்டும் இருக்கு. வால்யூம் அப்படின்னா என்ன, ஆக்சுவலா ஹைட் இன்டு ஐ மீன் லென்த் இன்டு பிரெத் இன்டு திக்னஸ் மூணையும் மல்டிப்ளை பண்ணாதான் வால்யூம் கிடைக்கும் இல்லையா. இங்க ஏரியா இருக்கு, ds இருக்கு, இது கூட டெல் எக்ஸ் மல்டிப்ளை, டெல் எக்ஸ்ங்கிற ஹைட்டும் இருக்கு. அப்ப இதை மல்டிப்ளை பண்ணா வால்யூம் தான் உங்களுக்கு கிடைக்கும். ரைட்டா. இதுல இருந்து we have to derive the we have to derive the surface charge. அத நான் என்ன பண்றேன்னு பாருங்க. left hand side is same but here it won't be 0. so this part I will erase. dn1 ds minus dn2 ds will be equal to, நான் இதை என்ன பண்றேன் அப்படின்னா இப்படி மாத்தி எழுதலாமான்னு எனக்கு சொல்லுங்க பார்க்கலாம். என்ன பண்றேன்னா இன்டகிரேஷன் ரோ v, இந்த dv அப்படிங்கறத நான் மாத்துறேன். என்னன்னு மாத்துறேன்னா del x into ds ன்னு மாத்துறேன். இப்படி எழுதலாமா? because area of this particular thing is ds with height del x. so area into this particular length நீங்க போட்டீங்கன்னா வால்யூம் கிடைக்குமா? so இந்த dv நான் இப்படி மாத்திட்டேன். ரைட்டா. இப்போ rho v கூட if I multiply a particular value, what will happen? it will become என்னங்க rho s அப்படினா ஆயிடும். கரெக்ட்டுங்களா? இப்போ நீங்க இன்டகிரேஷன் அது இதெல்லாம் மைனஸ் பண்ணீங்கன்னா என்ன கிடைக்கும்? dn1 minus dn2 is equal to rho s ன்னு கிடைக்கும், which is the answer. so இது உங்களுக்கு என்ன சொல்லுது அப்படின்னா ரெண்டு வேல்யூ ஈக்குவல் இல்லையா. அப்ப what does it mean? it is said to be discontinuous. so this is the second half of the second statement. என்னது otherwise name போட்டோம். if there is some surface charge density, if there is some charge enclosed in the pill box, so there automatically surface charge density will come into picture. so d will become discontinuous by an amount equal to surface charge density. so அதோட டிஃபரன்ஸ் வந்து surface charge density ஈக்குவலா வரும் அப்படிங்கிறது தான் இதனுடைய பாயிண்ட். இது யாருக்கு நான் புரியல? அதே மாதிரி இன்னொன்னு how rho v into del x will become 0 அப்படின்னு கேட்டீங்கன்னா இந்த ஹைட் இருக்கு இல்லையா, இத வந்து ரெடியூஸ் பண்ணா என்ன ஆகும்? ஹைட்டே இல்ல அப்படின்னா என்ன ஆகும்? வால்யூம்ங்கிறது it will be changed into surface. அதனாலதான் நான் வந்து இந்த ரெண்டை மல்டிப்ளை பண்ணும்போது I have written here as rho s, which is my surface charge density. Any doubt in this derivation? So continuous அப்படினா ரெண்டு வேல்யூவை ஈக்குவலா கொண்டு வரணும். et1 equal to et2 continuous, dn1 equal to dn2, it is said to be continuous. ஆனா dn1 உம் dn2 உம் ஈக்குவலா இல்ல, it is equal to some value அப்படினு சொன்னீங்கன்னா it will become discontinuous. சரியா? இதுல third part என்னன்னு கேட்டீங்கன்னா, we have got a small refraction. Shall I erase now? Have you all taken?
Yes, sir.
Okay. Third, ஒரு அந்த refraction lines of forces ன்னு சொன்னோம் இல்லையா, அதுக்கு ஒரு சின்ன derivation இருக்குங்க. எப்படி பண்றோம்னு பார்க்கலாம். I will be taking a graph wherein this is dn2 because I am taking medium 1 at the bottom, medium 2 at the top. So this is medium 1 whose permittivity is this, and this is medium 2 whose permittivity is epsilon 2. Okay, and this is actually a joint, right? And here I am taking et1, and this one I am taking it as et2. Okay, so this is my origin. So this angle I am taking it as theta1 in medium 1. இங்க வர்ற d value வந்து d1, e value e1 எடுத்துக்கலாம். So at origin what happens, இந்த faceல, இந்த surfaceல இது படும்போது இது வந்து ஒரு incident ray. Okay, so இந்த பாயிண்ட்ல படும்போது என்ன ஆகும், it will get refracted. Am I right? So this angle, sorry, this angle will become theta2. Okay, so இது என்னன்னு கேட்டீங்கன்னா d2 e2. Okay, so this is what the arrangement we are going to consider for our derivation of refraction lines of forces. The arrangement புரிஞ்சுதுங்களா? medium 1, medium 2, dn1, dn2, et1, et2. so இது வந்து incident ray இங்க originல படுது, இந்த faceல, இந்த jointல படும்போது என்ன ஆகும், it will get refracted. so on the incident angle or reflected angle is theta1, refracted angle is theta2. சரியா? Here the value is d1 e1 in medium 1, this is d2 e2 as in case of medium 2. இத வெச்சுக்கிட்டு we are going to derive it now. Okay, சரி, இப்போ நான் என்ன பண்றேன் அப்படினா dn1 என்னன்னு எழுத முடியுமா? using trigonometry dn1 வந்து இங்க வருதுங்க, கரெக்ட்டுங்களா? இப்ப theta1 இங்க இருக்கு, dn1 இங்க இருக்கு, ரைட்டா? எனக்கு இந்த சைடோட இது கிடைக்கும். இப்ப எது 90 டிகிரி ஆக்சுவலா? சோ இதுக்கு ஆப்போசிட் சைடு வர்றது ஆப்போசிட் சைடு, 90 டிகிரிக்கு ஆப்போசிட்டா வர்ற சைடு ஹைபோட்டென்யூஸ், இன்னொரு சைடு அட்ஜசன்ட் சைடு இல்லையா? இப்ப dn1 எனக்கு வேணும்னா எப்படி எழுதலாம்? I can write it as d1 cos theta1. Do you agree with this? யாருக்காவது அப்ஜெக்ஷன் இருந்துச்சுன்னா சொல்லலாம். அதே மாதிரி dn2 எப்படி எழுதலாம்? dn2ங்கிறது இங்க இருக்கு, that means d2 இந்த சைடு வந்து adjacent side, so it will become d2 cos theta2. இது வந்து first half. சரியா? நான் எழுதுற ஈக்குவேஷன்ல யாருக்காவது அப்ஜெக்ஷன் இருக்கு, டவுட் இருக்குன்னா சொல்லுங்க. In the same way I am writing the expression of et1. et1 இங்க வருதுங்க, இது என்ன சைடு? ஆப்போசிட் சைடு. ஆப்போசிட் சைடு அப்படின்னா sin வரும் இல்லையா? sin theta1 e1. so I can write it as e1 sin theta1. In the same way et2 வந்து என்ன ஆகும்னா e2 sin theta2, because et2 is here, so if I take this side it becomes opposite by hypotenuse. So this is the et2, this is e2. so sin theta2 is equal to et2 by e2. so sin theta, I mean et2 is equal to e2 into sin theta. இந்த நாலு போர்ஷன் நீங்க எடுப்பீங்க. இது எழுதுறதுல யாருக்காவது டவுட் இருக்காப்பா? இதை எழுதிட்டோம்னா நமக்கு half வேலை முடிஞ்சதுன்னு அர்த்தம். Okay. I hope there is no doubt. I'll come to this side now. See, after you have written this, from the boundary conditions, what is known to us? dn1 equal to dn2 அப்படின்னு நமக்கு தெரியும் இல்லையா? So dn1 அப்படிங்கிறது என்னங்க? d1 cos theta 1 equal to d2 cos theta 2. ஓகே, இதாவது ஈக்குவேஷன் 1 கூட வச்சுக்கோங்க, நோ ப்ராப்ளம். அடுத்தது இன்னொரு பவுண்டரி கண்டிஷன் நமக்கு தெரியும், et1 equal to et2 அப்படின்னு. அப்ப என்ன ஆகும் உங்களுக்கு? e1 sin theta 1 equal to e2 sin theta 2. You take this as second equation. இப்போ நீ என்ன பண்ற அப்படின்னு கேட்டீங்கன்னா, second divided by first equation பண்ணணும். இப்போ என்ன ஆகுங்க? second by first பண்ணீங்கன்னா பாருங்க, e1 sin theta 1 by d1 cos theta 1 equal to e2 sin theta 2 by d2 cos theta. What is sin by cos, ma? What is sin theta 1 by cos theta 1?
Tan theta, sir.
Tan theta. Also we know d and e can be written as என்னங்க? epsilon into e னு போடலாமா? அப்ப இது வந்து என்ன ஆகும்? d1 will become epsilon 1 e1 tan theta 1 equal to, in the same way here, e2 by epsilon 2 e2 tan theta 2. இப்போ இந்த e1 e1 கேன்சல் ஆகும், e2 e2 கேன்சல் ஆகும். பாக்கி என்ன இருக்குது? tan theta 1 by epsilon 1 equal to tan theta 2 by epsilon 2. இதை எப்படி எழுதலாம் அப்படின்னு கேட்டீங்கன்னா, I am writing it here, the final answer. Tan theta 1 divided by tan theta 2 equal to epsilon 1 by epsilon 2. இதுதான் என்னுடைய final answer. யாருக்காவது டவுட் இருக்கா ராஜா இதுல? Any doubts? Anybody? Yes, pa? Any doubts? Very simple trigonometry, mathematics மட்டும் தெரிஞ்சுனா போதும். We can definitely do it better. Very, very important thing, and very interesting derivation also. Any doubts? No doubt. Okay. Okay. I will close now the camera. Now I will come to the PPT. Not to teach something new, but what is there in the PPT that I want to show you. Okay. அதுக்காக I will come to the PPT. 1 minute. So this is the slide where we stopped our discussion. Right? So we have taken a rectangular box. So condition also has been written. Going to the next slide, applying it to what I am applying, v is equal to 0. That particular condition, if I apply it to the rectangle ABCD, what I will be getting? Then as the sides AB and CD are brought closer together, lengths will approach 0. So del x will be approaching 0, and I can get et1 equal to et2. If that is the meaning, what does it mean is E is said to be continuous at the surface. So thus statement 1 is proved. Next I will go for statement 2. For that I am taking a pillbox arrangement like this: medium 1, medium 2, dn1, dn2, del x is the height of the pillbox. What I am doing here, I am applying Gauss law to the pillbox at the boundary. Since there is no charges enclosed by the pillbox, q will be equal to 0. So dn1 equal to dn2, I can get it. Thus first half of statement 2 is proved. Next I am going to take the same pillbox arrangement again, but I will be taking I am assuming that there are some charges enclosed by the pillbox. What will happen now is right hand side will be equal to, not equal to 0, but it is equal to integration rho v dv. So dv I am writing it as dx into del x. So it becomes this one. Then I am taking height del x to be reduced to 0 at the boundary. So what will happen is limit del x tends to 0, rho v del x will become rho s. So dn1 minus dn2 equal to rho s I'll get. This is what is the proof for second half of the second statement. Then I am taking the third one, refraction arrangement, which we have seen recently. Here E1 is incident in medium 1 at an angle of theta 1. So theta 1 is said to be either reflected angle or incident angle. And E2 is the refracted electric field in medium 2 with an angle theta 2. So theta 2 is said to be refracted angle. Similarly, D1 is incident electric displacement in medium 1 and D2 is refracted in medium 2. The normal components of D can be written as dn1 equal to d1 cos theta 1 and dn2 equal to d2 cos theta 2. The tangential components of E can be written as et1 equal to e1 sin theta 1 and et2 equal to e2 sin theta 2. Applying the boundary conditions here, dn1 equal to dn2 and et1 equal to et2, I can get to the final expression as tan theta 1 by tan theta 2 is equal to epsilon 1 by epsilon 2. See, நீங்க derivation பண்ணும்போது என்ன உங்களுக்கு ஆன்சரா வரும், என்னென்ன தப்பெல்லாம் நீங்க நார்மலா பண்ணுவீங்க அப்படின்னா tan theta 1 by tan theta 2 equal to epsilon 2 by epsilon 1 ன்னு போட்டுருவீங்க. So I have seen lot of students just they will memorize. ஓகே, இது அப்ளை பண்ணீங்கன்னா ரொம்ப சிம்பிளுங்க, ஆன்சர் ஈஸியா வந்துடும். பட் அவங்க மக்கப் பண்ணிட்டு வரதுனால என்ன ஆகும்னா epsilon 2 by epsilon 1 ன்னு போட்டுருவாங்க. இல்லனா tan theta 2 மேல போட்டுருவாங்க, tan theta 1 நம்ம கீழே போட்டுருவாங்க. So some confusions they will definitely get while mugging, memorizing the answer. But there is no need to memorize this answer. Very, very simple points. Okay, so this is what is about boundary conditions. Next slide is regarding problems that we will see it because the time is up now itself. I have taken one more 1 minute extra from our class. Okay, ஏதாவது டவுட் இருக்கா ராஜா boundary conditions-ல? With this we will close our session. If there is any doubt that I will address, or otherwise we will stop.
No doubt, sir. Clear, sir.
Okay, it's clear. Okay. Anybody from B section? Because A section only is speaking. Aishwarya or Divyashri, Anjali, etc. Atisha. Okay. Anybody from B section? B section, any doubts? Okay, I think there is no doubts. Thank you so much for patient listening. Very important question we have seen now. We will meet again on Monday 3:15 to 4:15 session, and we will start our third module in that particular class. Thank you so much.
Thank you, sir.
Yeah, thank you.